Let's look at some examples in Chapter 12, Section 5, where we're solving inequalities. We solve inequalities very much like we solve equations, but we have to remember if we were to divide or multiply an inequality by a negative, we have to flip the inequality symbol. That's the only thing that we have to remember. Let's do this problem two different ways. Let's bring the minus 2x to the left, so it becomes plus 2x, and the 7 to the right, so it's negative 7. We're going to combine like terms, so that's minus x equals minus 5. We need to solve for x, which has a coefficient that is negative 1, so we divide both sides by negative 1. That's great, but we have to remember to change the inequality from less than to greater than. And I left off the equal sign, my fault. So it's x is greater than or equal to plus 5. An alternate way of doing the problem is because if we move all the x's to the left, we're going to get a negative coefficient, which could get me into trouble. So thinking ahead, I'm going to move the minus 3x to the right, so it's plus 3x. And therefore, I need to move the plus 2 to the left, so it's 7 minus 2. 7 minus 2 is 5. Minus 2x plus 3x is the 1x. We don't have to worry about any negative coefficient. We've already solved for x. It says, reading right to left, that x is greater than or equal to 5, which is equivalent to saying x is greater than or the equal sign that I left off, 5. Let's look at another problem. This one maybe is a little bit more challenging. Not much. We need to distribute first. So it's 2x minus 2 minus 3x is less than minus 1. We need to combine like terms. So we have minus x minus 2 is less than minus 1. We need to move like terms together. Minus x is less than minus 1 plus 2, which is equivalent to saying minus x is less than plus 1. Again, we need to get rid of the negative coefficient by dividing both sides by negative 1. Therefore, we have to flip the inequality symbol. So we went from less than to a greater than. X needs to be greater than minus 1. In an alternate way is to do the problem, as I suggested in the previous example, is to move the negative x term to the other side first. So the negative x term right here, if we move it to the right, it becomes plus x, and therefore we need to move the minus 1 to the left. So we have a total of negative 1. And we have the answer solved right away. Finally, let's look at an application involving inequalities. Always read the problem carefully several times. Define clearly the unknown. The unknown in this case is m. M is the number of miles that we need to drive to stay within the budget of $94. Let's write a statement that makes sense. We want to stay within budget. We can't exceed 94. So the budget for the car, 94, must be greater than or equal to the cost per day plus the cost for the miles driven. So the cost for the car that we can't exceed is $94. We can equal it. And the cost per day is $30. And for every mile we drive, it's 20 cents, so 0.20 times m. To solve this, we bring the 30 to the left, so 94 minus 94 is 64. 64 is greater than or equal to 0.2 m. Divide by the coefficient of 0.2. We're divided by a positive, so we do not need to flip the inequality symbol. That calculation on the left is equal to 320. rewriting this statement, again, read from the variable towards the known. It says m is less than or equal to 320. So when I write it that way, it says m less than or equal to 320.